Up until now, we've dealt with triangles where you see a picture and it has all the stuff in it, like angles and sides and so on. And you just need to solve for the missing things. Well, now I'm going to start giving you triangles in written form, which are described with sides and angles, but I don't actually draw you a picture. That's up to you. And this leaves open several new possibilities. One possibility is that there is just one triangle, like before. But there's also the possibility that I'm playing a joke on you, and there's no triangle possible. Okay, it's possible to describe a triangle. Like, say I described something like this. I said there's an angle here. I don't know what this side is, but we've got a side here that's A and a side here that's C. Actually, that would be B, because it's across from angle B. Now, you look at that and you're thinking, okay, that's not going to work. This little angle B is this stubby thing. It's not going to reach anywhere. I can't complete that triangle. So that's the scenario I'm talking about as a D&E triangle. You'll know them when you see them. Okay, your calculator's just going to tell you domain error or something like that, and none of your calculations will work. So we've talked about that one in class. I'm not going to dwell on that too much here in this problem, because for this particular question, I'm just trying to get at this concept of one triangle versus two triangles. We're not dealing with the annoying D&E case. Okay, so you can always assume there's going to be at least one possible triangle for this question. Now let's dive into the idea that sometimes you have two triangles, sometimes you have one. Let's go up here a little bit. This is some of the stuff we talked about in class, right? We've got our law of sines, and that's in both forms, sines on top or sines on bottom. And we're going to use that for all of these things. Now I'm talking about side-side angles here. Okay, you notice I haven't mentioned anything about the double angle triangles. When you have an angle-angle side triangle, that's easy. Okay, those are always one triangle. Okay, they're always one triangle solutions. You're never going to have something where you're not sure what the shape is. If you have two angles, for the reasons we talked about in class, you're always sure it's going to be one triangle, and you don't even have to worry about the D&E case. Okay, that one's always going to be nice. But this side-side angle scenario is where things get a little weird. Let's consider case number one. Okay, you have a side-side angle triangle, and the angle is obtuse. What that's going to lead you to is either one triangle is possible, or you're going to get the D&E situation where everything breaks. Okay, so that's fairly straightforward. Second scenario is where you have two sides in an angle, but that angle is acute. It's less than 90 degrees. Now this is where things get a little weird. You have to then examine the side which is opposite that given angle. Okay, so let me draw you a picture of what I mean here. If I have an angle, let's call that B, and here's side A and here's side B. Okay. If side B is longer than A, then you only have one possible solution. Okay, that's a scenario like this. See how long side B is compared to side A? That's going to lead to one possible triangle. All right? You don't even have to worry about the D&E in this case. But if side B is short, so that potentially, I don't have a good picture here for that, but let me draw another one. If side B is short, I'll show you what that might look like. Let's change colors here. So now I'm in the matching side is short scenario. Here's what happens. You've got a triangle that looks like this. Okay, some angle here, B, some side A, and some side B that is kind of short, compared to A anyway. Well, sure, maybe this is a nice picture. Okay, and you can imagine a triangle that looks like that. But you could also imagine that side B can swing this way and form another triangle. Okay, that works too. And we don't know which one of these it is. That's why this is called the ambiguous case. We have two possible shapes that could work for this scenario. Okay, so that's out of the way. Back to this. Your choices are one triangle exists, two triangles exist, or I'm not sure. It's not clear enough from the information given. Now, if you remember from what I just went over here, usually it's just one triangle possible. Okay, and let's walk through these and see why. Okay, let's see. So this is, I'm just going to write what types of triangles these are. That's side-side angle. This is side-side angle and side-side angle. And look at that, angle, angle, side. Remember what that is? That is always one possible triangle right there. And we have another angle, angle, side down here. Again, one possible triangle. And now we have, you know what? Let's change the colors around so this is a little more clear what's going on. When I have side-side angles, I'm going to call those orange. Side-side angle, side-side angle, side-side angle. And this last one is two sides given. All right, now, remember what produces ambiguous triangles. That was when the matching side is short. Okay, here we go. I see one right here. This case where I have side-side angle, and look at the important information. Acute angle, and the matching side is the shorter of the two sides. So that tells me this is the dreaded ambiguous case where you have two triangles possible. Each of these other ones is probably not two sides because there's no short side in those cases. So let's go through those. First one at the top, one obtuse angle and two sides are given with a matching pair. Okay, so it says there's a matching pair. That means I can use law of sines. It's side-side angle, and it's obtuse. So because it's obtuse, there is always one triangle possible in that case. It's obtuse, it has to be. And now, in the second scenario, I have one acute angle, two sides, so it's side-side angle, and there's a matching pair, so I can use law of sines on it. But it doesn't tell me whether the matching side is long or short. So this one is going to be not sure. Okay, I don't have enough information from this statement to say whether it's ambiguous, two triangles, or only a single triangle. And in this last case down here, okay, I'm looking at this guy now. With that last case, one angle, which is acute, and two sides, and the matching side is long. Okay, that means there is only one triangle possible.